Hello and good morning friends, welcome to CEC-UGC live lecture. Dear friends, as you know that we are carrying a series on artificial intelligence. So far we have conducted 2 lectures on artificial intelligence and this is the 3rd lecture on artificial intelligence. Today we would be learning more and you would be delighted to know that our today's expert has expertise on this area, that is on artificial intelligence, as well as expert systems, data mining are all his area of specializations. Yes, I am talking about Dr. U.S. Pandey. Dr. Pandey is Associate Professor in Department of Computer Sciences, School of Open Learning, University of Delhi. As well as Dr. Pandey has various research publications. Lots of scholars do their researches under him. So, taking advantages from his experiences, let's first of all welcome our guest Dr. U.S. Pandey. Dr. Pandey, welcome to the EduSet lecture. As through you, we try to understand about artificial intelligence, that how intelligence in comparison to the intelligence of the human being is created so that all the work could be done easily. So, sir, over to you again. Please explain us once again in detail what artificial intelligence is, and also please carry forward the lecture from where we left in the previous session. Over to you, sir.
Thank you. Thank you. Now, let us start with the natural language programming. Language is meant for the communicating about the world. By studying language, we can come to understand more about the world. If we can succeed at building computational mode of a language, we will have a powerful tool for the communicating about the world. We look at we can exploit knowledge about the world in combination with the linguistic facts to build computational natural language system. Natural language programming. NLP problem can be divided into 2 tasks: processing written text, using lexical, syntactic and semantic knowledge of the language, as well as the required real world information. Processing spoken language using all the information needed above plus additional knowledge about phonology, as well as enough added information to handle the further ambiguities that arise in speech. Steps in NLP. Morphological analysis. Individual words are analyzed into their components and non-words token such as punctuations are separated from the words. Syntactic analysis. Linear sequences of words are transformed into structures that show how the words relate to each other. Semantic analysis. The structures created by the systematic analyzer are assigned meaning. Discourse integration. The meaning of an individual sentence may depend on the sentences that precede it and may influence the meaning of the sentences that follow it. Pragmatic analysis. The structure representing what was said is reinterpreted to determine what was actually meant. Morphological analysis. Suppose we have an English interface to an operating system and the following sentence is typed: I want to print bills dot init file, full stop. Morphological analysis must do the following things: pull apart the bills into proper noun, bill and the possessive suffix s. Recognize the sequence .init as a file extension that is functioning as an adjective in the sense state. Morphological analysis. This process will usually assign syntactic categories to all the words in the sentence. Consider the word prints. This word is either a plural noun or a third person singular verb. He prints. Syntactic analysis. Syntactic analysis must exploit the results of morphological analysis to build a structural description of the sentence. The goal of this process, called parsing, is to convert the flat list of words that forms the sentence into a structure that defines the unit that are represented by that flat list. The important thing here is that a flat sentence has been converted into a hierarchical structure and that the structure corresponds to meaning units when semantic analysis is performed. Reference makers are shown in the parenthesis in the phrase T. Each one corresponds to some entity that has been mentioned in the sentence. Look at the semantic analysis. You see the AS, RM1, NP, VP, we decide this pro, RM2, VP, and we want this S, RM3. I want to build the init file. So, you can see how those print, adjectives and all have been defined. Semantic analysis. Semantic analysis must do two important things. It must map individual words into appropriate objects in the knowledge base or database. It must create the correct structures to correspond to the way the meaning of the individual words combine with each other. Discourse integration. Especially, we do not know whom the pronoun I or the proper noun Bill refers to. To pin down these references require an appeal to a model of the current discourse context, from which we can learn that the current user is user 068 R and the only person named Bill about whom we called be talking is user 073. Once the correct referent from the bill is known, we can also determine exactly which file is being referred to. Pragmatic analysis. The final step forward effective understanding is to decide what to do as an results. One possible thing to do is to record what was said as a fact and be done with it. For some sentences whose intended effect is clearly declarative, that is precisely correct thing to do. But for other sentences, including the one, the intent defect is different. We can discover this intended effect by applying a set of rules that characterized cooperative dialogues. The final step in pragmatic processing is to translate from the knowledge based representation to a command to be executed by the system. The results of the understanding process is LPR / W Smith / step INT. What is intelligence? Intelligence is the ability to learn about, to learn from, to understand about and interact with one's environment. Intelligence is the faculty of understanding. Intelligence is not to make no mistakes, but quickly to understand how to make them good. That is said by a German poet. What is an artificial intelligence? Artificial intelligence, AI in short, is usually defined as the science of making computers to do things that require intelligence when done by humans. AI is the study of ideas that enable computers to be intelligent. How does AI works? Artificial intelligence works with the help of artificial neurons, artificial neural network and scientific theorems, like we say if then statement logistics. The foundation of artificial intelligence. Philosophy 423 BC to present, logic, methods of reasoning, minds of a physical system, foundation of learning, language and rationality. Mathematics c. 800 to present, formal representation and proof, algorithms, computations, decidability, tractability, probability. Psychology 1879 to present, adoption, phenomena of perception and motor control, experimental techniques. Linguistics 1957 to present, knowledge representation, grammar. A brief history of artificial intelligence. The gestation of the AI 1943 to 1956. In 1943, McCullough and Pitt's Boolean circuit model of brain. In 1950, Turing's computing machinery and intelligence. In 1956, the McCarthy's name artificial intelligence adopted. Early enthusiasm, great expectation, that is from 1952 to 1969, early successful AI programs, Samuel Checkers, Newell-Simmons logic theorist, Gestarner's geometry theorem prover, Robinson's complete algorithm for logical reasoning, a dose of reality, 1966 to 1974, AI discovered computational complexity. Neural network research almost disappeared after Minsky's papers book in 1969. Knowledge-based systems, 1969 to 1979, 1969, Dendral by Bookman, 1970, Mycin by Sartefeld, 1979, Prospector by Duda. AI becomes an industry, 1980 to 1988. Expert system industry booms. 1981, Japan's 10th year 5th generation project. The return of Enans and the novel AI, 1986 to present. Mid-80s, backpropagation learning algorithms reinvented. Expert systems industry busted. In 1988, resurgence of the probability. In 88, novels AI, Alive, GA, soft computing and all. In 1905, agent everywhere. 2003, human level AI back on the agenda. What is neural networking? Artificial neural networks are composed of interconnecting artificial neurons, that is programmable constructs that mimic the properties of biological neurons. Structure of a biological neuron, here you can see dendrites accept the input, soma processes the input, axon turns the processed input into outputs. Synapses, the electrochemical contact between neurons. Here you can see the structural axons and the dendrites, the way of the functioning. An artificial neuron, you can see the axons, synapses, dendrites and body soma. Axon is giving an output. Turing test, imitations game test. The Turing test is the test of machine's ability to demonstrate intelligence. Here you can see A and B and these machines have been shown in the form of C. Chinese room test, a counter argument to Turing test. Here you can see, if you can see this shape followed by the different shapes, followed by this shape, then produce these different shape and followed by this shape. Intelligent agents, you can see the agent, sensor and actuators, percepts and actions are going to be things are here in environment. Example of artificial intelligence, as we have discussed a lot about the expert systems. An expert system is a computer program that is designed to hold the accumulated knowledge of one or more domain expert. reason with knowledge of some specialist subject with a view to solving problems or giving advice. They are tested by being placed in the same real world problem solving situation. Application of expert system. Here you can see that PUF, a medical system for diagnosis of respiratory conditions. Prospector is there, used by geologists to identify sites for drilling or mining. Another expert system, Dendral, used to identify the structure of chemical compounds, first used in 1965. Lithion gives advice to archaeologists examining stone tools. Machine learning. Machine learning is a scientific discipline concerned with the design and development of algorithms that allow machines to mimic human intelligence. There are three ways that artificial intelligence learns: failure driven learning, learning by being told, learning by exploration. Here you can see the resemblance of the human mind. The special ability of artificial intelligence is to reach a solution based on facts rather than on a preset series of steps, is what most closely resembles the thinking function of a human brain. Here you can see that the human intelligence versus artificial intelligence, how it is going to be different when we are thinking and what machine is thinking is going to be different. Now, here in the case of human intelligence, intuition, common sense, judgment, creativity, beliefs, etc. In case of artificial intelligence, it is ability to simulate human behavior and cognitive process. In case of human intelligence, the ability to demonstrate their intelligence by communicating effectively. In case of artificial intelligence, it is capture and preserve human expertise. In human intelligence, possibly reasoning and critical thinking. In case of AI, fast response, the ability to comprehend large amount of data quickly. Humans are fallible. Humans, they have a limited knowledge base. Information processing of a serial nature process very slowly in the brain as compared to the computers. Humans are unable to retain large amount of data in memory. In case of AI, no common sense, cannot readily deal with the mixed knowledge, may have high development cost, raise legal and ethical concerns. You can see that the human intelligence versus artificial intelligence, a natural stupidity is no match for artificial intelligence. We achieve more than we knew. We know more than we understand. We understand more than we can explain, this said by this Claude Bernard in 19th French scientific philosopher. Here, the artificial intelligence versus conventional computing. In AI, artificial intelligence software uses the techniques of search and pattern matching. In case of conventional computing, conventional computer software follow a logical series of steps to reach a conclusion. In artificial intelligence, programmers design artificial intelligence software to give the computer only the problem, not the steps necessary to solve it. Computer programmers originally designed software that accomplished tasks by completing algorithms. Artificial intelligence and our society. Why we need artificial intelligence? To supplement natural intelligence. For example, we are building an intelligence in an object so that it can do what we want it to do. As for example, a robot that reducing human labor and reducing human mistakes. My perspective for human intelligence, no more than talking a right decision at right time, and for machines, artificial intelligence is no more than choosing a right decision at right time. I think artificial intelligence is the second intelligence ever to exist. What is AI? Thinking humanly, thinking rationally, acting humanly and acting rationally. Acting humanly, the Turing test. Alan Turing in 1912 to 1954, the computing machinery and intelligence in 1950, imitations came, human interrogator and the human and AI system. Acting humanly, the Turing test predicted that by 2000 a machine might have a 30% chance of fooling a lay person for 5 minutes. Anticipated all major arguments against AI in following 50 years. Suggested major components of artificial intelligence: knowledge, reasoning, language, understanding, learning. Thinking humanly, cognitive modeling. Not content to have a program correctly solving a problem, more concerned with comparing its reasoning steps to traces of human solving the same problem. Requires testable theories of the workings of the human mind, that is cognitive science. Thinking rationally, law of thoughts. Aristotle was one of the first to attempt to codify right thinking such that irrefutable reasoning processes. Formal logic provides a precise notation and rules for representing and reasoning with all kinds of things in the world. Obstacles, informal knowledge representation, computational complexity and resources. Actual rationality, acting so as to achieve one's goal, given one's beliefs, does not necessarily involve thinking. Advantages, more general than the law of thoughts approach, more amenable to scientific development than human-based approaches. Task domains of AI, mundane task, perception, where vision, speech, natural languages, understanding, generation, translation, common sense reasoning, robot control, and formal tasks are games, so that chess, checkers, etc., mathematics, geometry, logic, proving properties of programs, expert tasks, engineering, design, fault finding, manufacturing, planning, scientific analysis, medical analysis, financial analysis, and now AI techniques. Intelligence requires knowledge. Knowledge possesses less desirable properties such as voluminous, hard to characterize accurately, constantly changing, differs from data that can be used. AI techniques is a method that exploits knowledge that should be represented in such a way that knowledge captures generalization. It can be understood by people who must provide it. It can be easily modified to correct errors. It can be used in variety of situations. The state of the art. Computer builds human in a chess game. Computer human conversation using speech recognition. Expert system controls a spacecraft. Robot can walk on stairs and hold a cup of water. Language translation for web pages. Human appliances use fuzzy logic. Tic Tac Toe. 3 programs are presented. Series increase, their complexity, use of generalization, clarity of their knowledge, extensibility of their approach. You can see the introductory problem, Tic Tac Toe. Here you can see that the 9 squares are there and these things are been put. Now, introductory problem, say program 1. We are just explaining the data structure. Board, 9 element vector representing the board with 1 to 9 for each square. An element contains the value 0 if it is blank, 1 if it is filled by X or you can say class, or 2 if it is filled with a 0. Move a table. A large vector of 19,683 element, 3 to power 9. Each element is 9 element vector. Algorithms. View the vector as a ternary number, convert it to a decimal number, use the computed number as an index into a move table and access the vector stored there. See the new board of that vector. Comments. This program is very efficient in time. A lot of space to store the move table, a lot of work to specify all the entries in the move table, difficult to extend. Another introductory problem, if we fill up the gap 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, this program 2, data structure, a 9 element vector representing the board, but instead of using 0, 1 and 2 in each element, we store 2 for blank, 3 for X and 5 for O. Functions. Make 2, returns 5 if the center square is blank, else any other blank square. Pause when we return 0 if the players P cannot win on his next move. Otherwise, it returns the number of square that constitute a winning move. If the product is 18, that is 3 into 3 into 2, then X can win. If the product is 50, that is 5 into 5 into 2, then O can win. Go and makes a move in the square. Strategy: turn is equal to 1, go 1, turn equal to 2. If board 5 is blank, go 5, else go 1, turn 3. If board 9 is blank, go 9, else go 3. Turns 4, if pos win X is not equal to 0, then go pos win X. Introductory problem Tic Tac Toe comments. Not efficient in time, as it has to check several conditions before making each move. Easier to understand the program's strategy. Hard to generalize. Same problem in a different way. 8, 3, 4, 1, 5, 9, 6, 7 and 2. 15 minus 8 plus 2. The comment is checking for possible win is quicker. Human finds the row scan approach easier, while computers find the number of counting approach more efficient. Program 3. If it is a win, give it is the highest rating. Otherwise, consider all the moves to the opponent could make next. Assume the opponent will make the move that is worst for us. Assign the rating of the move to the current mode. The best mode is then the one of the highest rating. Introductory problem, Tic Tac Toe comments require much more time to consider all possible moves. Could be extended to handle more complicated games. Introductory problems, question answering. Many went shopping for new coat. She found a red one she really liked. When she got it home, she discovered that it went perfectly with her favorite dish. Question 1. What did Mary go shopping for? Why did Mary find that she liked? Did Mary buy anything? Here the introductory problems question answering is program 1. Match predefined templates to the questions to generate text patterns. Match text patterns to input text to get answers. What did XY? What did Mary go shopping for? Mary go shopping for Z. Z is a new code. Now, the program 2 is structured representation of the sentence in the event 2, instance and finding, tense, past, agent, Mary, object, think 1, and think 1 is instance, a code, and color is red. And thank you all about these problems.
Thank you, sir. Thank you so very much for explaining us in detail regarding the topic artificial intelligence, as we would be conducting another lecture on artificial intelligence. So, what else are we going to study in the future lectures?
Future lectures also we are going to go about the detail about the artificial intelligence, as we have just discussed today about the natural language processing and how the logics are going to be built up in the artificial intelligence for a particular problem, because you understand it's very easy when you are just talking about any problem or resolving any kind of thing. So, what are the steps happening in our mind that need to be defined into the computer system, be the logics. For example, as we have just mentioned, we have taken some problems where the different activities have been defined. As we have discussed, chess or other different kind of problems, or mathematical problems are there. When you are going to solve it, what are the steps are going to be involved? What other kind of properties can be built into that? And if some kind of techniques have been inbuilt in, what are going to be the impact of those onto the results? These need to be defined. That too in a proper way, in a algorithmic way, in a programming way. So, that is the different techniques of artificial intelligence. We are going to discuss something more about there in the coming lectures, and these are the things which we have discussed today about that.
Because we have some few minutes left, so let's have a quick review on what we studied today. As you explained about the natural language processing, please in few words explain for the students who might have just switched on.
As we have just said, Geetika, very well, natural language processing is basically, it's a very easy, how in a easiest way a computer can understand your the thing, the knowledge and all. Say, as we have understand by the meaning, we have just talked about the neural network. Artificial neural net. We just give an example like that. We can represent many things by a small picture. Just take a small case. Some quizzes are being organized. Now you see on the mobile phones different apps. Now some pictures have been shown to you. This is a apps for this WhatsApp. This is a app picture for a particular Hotmail. This is application picture for a particular. Just looking on your mobile phone, just looking on that particular photo, you are able to understand which apps is for what. So, what do you mean by that? How you are going to recognize that? What sense your mind to say that this application is for that purpose? Here comes this kind of neural networks and all. You can see as you are going on a street, going on a way, on a road, you see some different symbols are present on there. Those symbols are indicating something. As we have just mentioned earlier also, that if you are going for a say Olympic games, there are many games are being organized. For each game, the details need not to be specified each and every places. On a small board, they display just by using few symbols, that this is a symbol for hockey, this is a symbol for cricket, this is symbol for baseball, this is symbol just by one small line and some small ball. So these symbols indicate that you can easily understand this, which games are going to be there. This is one example. So in a many way, the neural network here, this and natural language processing, these are going to play a very important role. In other way, we can a significant role in playing and taking the different kind of decisions. We have discussed today about the biological neuron system, how our brain functions. We are not exactly taking the biological thing, but the way we would like to put the thing to develop an expert system. We are just thinking that how a robot can be made, just like in a human brains, the dendrites are there, synapses are there, the neurons are there, the way they are acting, how the informations are being stored in your mind, and when you require it, you are accessing through your mind, your database in your mind. In the same way, we would like to do the processing in the computers also. As we know, the storage of information in mind, you cannot store a large amount of data. Some of people can do it, but not everyone can store. But in computers do have a build up this kind of capability, just like happening in the mind. We can do lot of activity using this computational activity. The way mind performs the activity, we have discussed about that also, how the brain thinks, what are the beliefs and about the major concerns we have, and the different knowledge through the conventional system, how it differs from that. But still lot of activities are taking place, a lot of research is going on to do much more good development in this particular area.
With this note, thank you, sir. Thank you so very much for delivering such a nice lecture and explaining us in detail what is natural language processing is. And we covered another lecture on artificial intelligence, and I would like to tell you all that Dr. Pandey would be again with us tomorrow, and we would be discussing more on the artificial intelligence. If you wish to access this particular lecture, definitely you can access with the help of the YouTube, because daily we upload our lectures on the YouTube. Thank you, sir. Thank you so very much for being the part of the EduSet lecture. Thank you.